my name is Lynn Ortiz, and I am a student learning specialist over in the Center of Academic Success. Today in this video, I will be covering dimensional analysis tips that other students and myself have found beneficial in setting up equations for your dosage calculations. So let's go ahead and get started. The first one is to start with the end in mind. Usually when we do this, it's a unit over another unit, and examples include milliliters over hour, tablet per dose, or drops per minute. The second tip is to identify distractors. These would be anything that cannot cross-cancel. Keep in mind that any unit over the same unit is equal to 1, and that's how you cross-cancel. If you cannot cross-cancel, and if it also is not what you're solving for, then technically it is considered a distractor. The third tip is knowing your conversions by heart. You absolutely need to know every single one of these by heart. The fourth tip is to calculate last. I know a lot of us like to go ahead and calculate and get our calculators out, especially when it comes to conversions. But if you set up your equation correctly, calculating will be done at the very end. And last but not least, read the question carefully. This means knowing how to round, whether in the tenths place, hundredths place, or by whole number. Thank you. When it comes to conversions, the key thing to keep in mind is that with the metric system uses 1,000. So for example, 1 kilogram is equal to 1,000 grams. 1 gram is equivalent to 1,000 milligrams. 1 milligram is equivalent to 1,000 micrograms. Additionally, a lot of students struggle with these common conversions here. We have 1 kilogram is equal to 2.2 pounds. 30 milliliters is equal to 1 ounce. 1 teaspoon is equal to 5 milliliters. 1 tablespoon is equal to 15 mLs or 3 teaspoons. Even though these are common ones that students struggle with, you still need to know the conversions by heart, and you can come into CAST at any time to receive the conversion handout. When it comes to decimal placement, we have a whole number, the tenths place, and the hundredths place. For example, we have 1.34. The 1 is in the whole number place. You have 3 in the tenths place and 4 in the hundredths place. When rounding up, and in this example, we're going to round up to the tenths place, we take the number, and if it's greater than or equal to 5, then we round up. For example, we have 1.78. We take the 8 that is in the hundredths place to round up the number in the tenths place. So 1.78 becomes 1.8. Rounding down to the tenths place, we round down if the number is less than 5. For example, we have 3.14. We take the 4 that's in the hundredths place, and we determine that 3.14 becomes 3.1. When rounding, there are units that will always round to the whole number place. For example, drops per minute. Additionally, there are units that will likely round in the whole number place or 0.5. For example, tablets. Okay, now that you know some dimensional analysis tips, how to round, decimal placement, and conversion tips, let's go ahead and get started. Are you ready? Okay. The client is prescribed Strattera 100 milligrams by mouth daily. Strattera is available in 25 milligram capsules. How many capsules will the client receive per dose? Let's start with the end in mind. How many capsules will the client receive per dose? What I like to do is I like to figure out the unit over the other unit that they are asking for. It's asking for capsules per dose. And I like to box that off like this, okay? We also like to think of these two units as relationships to one another. So a numerator over a denominator. And I always like to look for the numerator first. So what do we have here that shows us capsules? We have 25 milligram capsules. So one capsule is equal to 25 milligrams. Are you with me? I hope you are. But we see that the numerators here match, but the denominators do not. So we have to cross cancel. How do we get rid of the milligrams? Right, so we get the 100 milligrams on top here. And it says by mouth daily. But the problem with this is that I like to think of daily as a distractor. All this is really telling us is that 100 milligrams is being given at equal intervals. If it's being given at equal intervals, what that really means is that it's being given as a dose. So this means per dose. So we are going back here, 100 milligrams per dose. Next step is we cross cancel. We can cross cancel a unit that is the same as its other unit, okay? Milligrams and milligrams will cancel each other out. The last thing that I like to do is circle what I have left. I have capsules here and I have dose here. My numerators match. My denominators match, and now, last but not least, I can go ahead and calculate. 100 capsule over 25 dose. Go ahead and calculate. 4 capsules per dose. Let's do another practice question. We have a client that weighs 110 pounds and is to receive medication 2 milligrams per kilogram. How many milligrams will the client receive? So we have to think about the end in mind. What unit are they asking us for? It's listed here in the last sentence. It's asking us for milligrams. So like I said before, I like to write the unit and box it off. So we are solving for milligrams. What do we have here that shows milligrams? 2 milligrams per kilogram. So let's start off with that. We have 2 milligrams as the numerator over kilograms. Before I proceed, I wanted to make a point here that if you have a unit by itself, all that really means is a milligram over 1. Okay, so a unit over 1. Just to see if that helps you any further, okay? The next thing here is we do not have anything in there that has kilograms. So, that being said, we have to convert. Remember that a unit over itself is equal to 1, and we are trying to get rid of kilograms here because it does not equal 1. So we know that 1 kilogram is equal to 2.2 pounds. What else do we have here that indicates pounds? We have the patient's weight, 110 pounds. 110 pounds. We can cross cancel our kilogram here, and we can cross cancel our pounds here. We circle the units that we have left with this, just the milligrams. Milligrams equals to milligrams, therefore we can go ahead and solve. 2 times 110 is equal to 220 milligrams over 2.2. Go ahead and take your calculators out. Your answer should be 100 milligrams. Okay. One more practice question. We have the client weighing 100 kilograms was prescribed nitroprusside 15 milliliters an hour intravenous IV drip. The available concentration is 50 milligrams in 500 mLs of 5% dextrose water. How many micrograms per kilograms per minute of nitroprusside is the client receiving? So we think of the end in mind. We know that they are asking for micrograms per kilograms per minute. I know that tends to be very confusing when we have 3 units. So what I tell students is that you're going to have one numerator, and anything else that follows that first unit is going to become your denominator, okay? So you have kilograms over minute is going to be your denominator, okay? So in order to cross cancel, if you need to cross cancel any of these, they will show up on top, okay, as the numerator. So let's see what we can find for micrograms. What do we have in the problem that has micrograms? We don't have anything that has micrograms, so we can go ahead and try a conversion, okay? So let's convert here. And we know that 1,000 micrograms is in 1 milligram. But we know that these two do not match, so we need to cross cancel that. So what do we have here that has milligrams? Hold on, pause, sorry. Okay. So where do we have another milligram? We have 50 milligrams inside the problem here, so we could use the 50 milligrams, which we know is in 500 mLs. So now we can cross cancel the milligrams, but now we have micrograms over milliliters. So we need to get rid of the milliliters here because these two do not match. So where do we have milliliters? 15 mLs per hour. So we can do 15 mLs over 1 hour. So we can cross cancel the milliliters here. But again, we have hour here and we have kilograms per minute. We need to get rid of the hour. We know that in 1 hour, there is 60 minutes. So 1 hour is equivalent to 60 minutes. Then we can cross cancel these two. And then here's the other thing that's pretty difficult for other students to understand here is that you have a patient weight that is 100 kilograms, right? We know that it's a denominator that needs to be on the bottom. So one thing that I tell students is that 1 always acts as your placeholder. So you have 1 over 100 kilograms. Let's look at the units that we have left. We have micrograms here, we have kilograms here, and we have minutes here. So you have micrograms per kilogram per minute. So now we can go ahead and solve. When you multiply all of this across, you get 750,000 over 3 million. And your answer becomes 0.25 micrograms per kilograms per minute. Thank you.